All right, guys, we're going to do a short introduction to the transformations that you guys have done so far. So we're going to do reflections, translations, and rotations, just to make sure that you guys are understanding everything okay. So reflections are figures that are going to flip over any given line, or maybe your x-axis or your y-axis, and it's going to maintain the same size and the same shape. So if you start with a square, you should always have a square. If you start with a triangle, you should have the same size triangle after you reflect. Points are going to be equal distance away from whatever line of reflection that we're doing. And so what's going to happen is if we're reflecting over the x-axis, and if we have a point here, the point is going to change and it's going to come down here because this is a reflection over the x-axis. And so what happens is the x-coordinate point is the same. So if this one went up 1, so this is a positive 1, it's going to come down here and it's a negative 1. So it's the y values that are changing or becoming negative. Okay? So if we're reflecting over the y-axis, let's say that we had this point here and I went over 2 and I went up 1. So if I reflect it, it's going to reflect over here because it's going to flip. It's like if I folded the paper right here, it would flip to be over here. So when I do that, it goes 1, 2. So this was at a negative 2x value. And the new point, or your image, is going to be, so this is the pre-image, and this is the image. So the new point is going to be at a positive 2. And this time it is your x value that changes. So when I look at the coordinate points, if I have A, B, C, D, so A, B, C, and D, we're going to write these coordinate points in here. So negative 2, negative 8 was the first one. And if we're reflecting over the x-axis, it is the y value that becomes negative. So it's going to be a negative y. And that's using the rule that we had up here. So x is going to stay the same. X was negative 2. We're not changing x. Instead of a negative 8, we're now going to have a positive 8. Same thing here at B, it's at 5, 10. Your x value stays the same. Your y value is going to switch and be opposite. So we have 8, 7. It's going to become 8, negative 7, and negative 2, 11. The negative 2 stays, and then instead of a positive 11, we have a negative 11. Okay. Some of you guys had questions about what happens from a graph. So we have the same figure, but this time we're going to reflect over the y-axis. So this is our y-axis, we're going to label it. And we can write the coordinate points, and we can say that t is at negative 1, positive 2. R is at 1, 2, 3, 1, 2, 3, 4, so 3, 4. And then y is at 1, 2, 1, 2, so 2, 2. So if we're flipping over the y-axis, x is going to become negative x. So if I rewrite my coordinate points, t prime, because remember prime is going to be our image, is going to be at 1, 2, because x changes, y stays the same. R prime is going to be at negative 3, 4. And then y prime is going to be at negative 2, 2. So you can notice that all of our x values right here changed, y stayed the same. So I can plot these points, and it's over 1, up 2. This point is going to be our new t. Negative 3, 4. So 1, 2, 3. 1, 2, 3, 4. And this is our new r. So I'm going to put the little tick mark up here to show that it's a prime. Negative 2, 2. 1, 2, 1, 2. And this is y prime. So our shape is the same, and if I were to fold my paper right here, if I were to fold it, these points would fold and they would match up. So they are the same distance from our y-axis. 1, 2, 3, 1, 2, 3. So since they're both three units away from our y-axis, we know that they would match and they're the same. Now, there was a question yesterday that we had over our Google Meet about if we have something that is other than an x or y-axis. So right here we have the question of y equals 2. So you guys can see this red line here, and this line right here is when y equals 2. And we're going to plot all of these points. So j is at 0, 0. U is at 4, 0. So 1, 2, 3, 4, stay at 0. M is at 4, 6. So 4, 1, 2, 3, 4, 5, 6. And P is at 0, 5. So we have this trapezoid here that we are going to reflect over this line. So instead of reflecting over the x-axis, we're reflecting over this line right here. So it's going to be the same thing as what we were doing before, and if you remember, we were counting the distances away here, and we noticed that the distance is the same. So if this was 1, this was 1. So we can look at this line here, and from the red line to get to J, we went up 2 units. So we can also go down 2 units, and so this is J prime. So J was at 0, 0. So J was at 0, 0, and J prime is at 0, negative 4. U, we went to 4, 0. Okay, so this was at up 2, so I have to go down 2, 1, 2. And this is going to be U prime. And we went over 4, but this time we went down 4. So this is 4, negative 4. P, from here, we have to go 1, 2, 3, 4, 5, 6, 7. So we went up 7 units, so we have to do the same thing here. 1, 2, 3, 4, 5, 6, 7. We're going down 7 units, and this is P prime. So this coordinate point here, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, we went down 9, so this was at 0, negative 9, where this one was originally at 0, 5. Going a little out of order here. And then M, we went up 1, 2, 3, 4, 5, 6, 7, 8. So we have to go down 8 from our red line. 1, 2, 3, 4, 5, 6, 7, 8. And this is M. So M is now at 4, negative 10, where originally it was at 4, 6. Sometimes it's easier to count the distance because it is equidistance. And sometimes it's easier to use our rules. So our rules work if we were doing x-axis and y-axis. When we were doing something other than our x-axis, y-axis, it was easier to count the distance away to be able to create our new shape and then to be able to write our coordinate points for our image. So that's a short introduction on reflection.